Welcome. So today we have Professor Raghvendra Gadakar from Indian Institute of Science, a renowned evolutionary biologist who worked on social insects, and he happens to be fellow of all the 3 Indian National Science Academies. So welcome Professor Gadakar to Punjabi University.
Thank you, it's my pleasure.
Yeah. So just let me know about your journey as a scientist.
As far back as I can remember, I wanted to be a scientist, but I didn't know what science was. And I realized that the reason why I want to be a scientist is because I was curious. And I realized now that science should actually be a curiosity driven, playful activity. Unfortunately, it is not always like that, and I have tried to promote the idea that science should be a playful, curiosity driven activity. I went through the usual school and college, and I stuck to science for a long time, but I was also interested in lots of other things. In fact, one thing that may surprise you is that my second passion when I was in high school, in addition to biology, was Hindi literature. And my Hindi teacher said, you must go into Hindi literature. And my biology teacher said, you must become a biologist. And I said, can I not do both? And they laughed and said, no, you can't do both. You have to choose one. So I chose biology, and I was interested in biology for a long time. I did some small experiments at home, keeping laboratory mice at home. And I built a microscope by myself at home from things available. And I studied the estrous cycle of mice at home, made slides, stained them using my microscope, and for that I was awarded the National Science Talent Scholarship. And that allowed me then to go to do BSc Honours in Zoology, MSc in Zoology. During my BSc Honours, in fact first year of my BSc Honours, I encountered nests of this wasp Propyladia marginata, which I now study. They were building on every window in the, and surprisingly my zoology teachers didn't know what they were and didn't particularly care what they were, because those days zoology was taught in the manner of studying dead animals preserved in formaldehyde in bottles. Very little attention to living animals. But I was fascinated. I kept looking at them, I stared at them, and I kept this passion till I finished my BSc Honours and MSc. But I also became equally interested in molecular biology, and I wanted to study both these subjects. Again I had this problem, and people said, you cannot do both, and for my PhD. And at that time nobody was capable of or available to guide me for a PhD in animal behavior. But the Indian Institute of Science, which is probably the best institute in the country, gave me admission, and they had just one position for molecular biology, and they gave it to me. So I jumped at it. For 5 years I did my PhD in molecular biology, loved it even more, but continued to work with my WAS as a hobby, continued to publish in both the fields. And at the end of my PhD I had a real dilemma. Again two, which one should I do for further? And those days it was not possible to do both. Today it is easy to combine molecular biology and animal behavior. Those days it was unheard of. And I could not choose between them because I loved them equally. Then I told myself, if I want to continue in molecular biology, I want to go abroad, because the facilities here were very poor and we were not able to do at the cutting edge. But if I want to continue to study my animal behavior using my WAS, I should not go anywhere, I should stay here. So I asked myself, where do I want to live? And I said, of course I want to live in India, preferably in Bangalore. That's how I chose this. So I converted my hobby into my profession and my profession into my hobby. Till today, molecular biology is my hobby and animal behavior is my profession. That's how I continue to study these wasps throughout my career.
So you have focused on one organism as your model organism, and sometimes I see that people are doing too many things at one time. So what is your viewpoint about this?
See, there are many ways of doing this. You can study many species superficially or one species in great detail. Now, my method is to take one species, spend your whole life on it. Now, if this is the only method that we are using, then very few species will get studied. So I think it's also important for some people to look at a large number of species somewhat superficially and use phylogenetic and other techniques to understand. So both are important. It depends on your personality. My personality is such that I am in love with my wasp. So I said, until I understand this fully, why should I study another species? And I will never understand it fully. But there are many people who are attracted, saying there's another one, there's a butterfly. So I think both are valid, and people should choose based on their individual psychology.
That is fine, but sometimes down the line, this kind of approach may lead to a kind of reductionism in biology. That is, if you are specializing in something, for example, in immunology or some molecular biology, and you are not deviating, or you do not know the other aspect of that particular organism, it becomes very difficult.
Yes, we confuse between techniques and phenomena. We make a confusion. So you cannot just be a specialist in a technique. The purpose of a technique is to understand phenomena. So very often, because mastering a technique, using it, getting all the infrastructure necessary to be able to apply the technique takes so much time, so much energy, that people make the technique an end in itself, which is not a very useful thing. Techniques are very important, but they should be used to study phenomena, and therefore phenomena become very important, and especially phenomena at the organismal level become very important. So I think we should have both. We should have large number of people studying phenomena, a few people specializing in techniques, and then collaborating. So we need to build a pyramid where there are lots of people studying phenomena, fewer and fewer people specializing in techniques. So we need a pyramid like this and not the other way around. That's why I feel the vast majority of biologists should be organismal biology. In fact, the maximum number should be taxonomists, because first you have to describe the species. Then you have people who study organismal biology. Fewer and fewer people study molecular biology, immunology and other aspects and apply them to all of this. We need to maintain this pyramid, only then it will be stable. Unfortunately, now we are making often an inverted pyramid.
Yes.
Very few people study, almost no taxonomies, and lots of people are armed with technology. What do you do with that technology? So we need to reverse this. That's why I was so happy to see the botanical garden in the university today, and I was speaking with your botany professors that you should use this to enthuse lots of people to do what is called classical biology. And there is nothing to be ashamed of classical biology. It's a wonderful thing to do. Lots of people should do it, and we need to build that pyramid.
So along your career, you have seen a sort of transformation, right, from classical biology to what is happening now. So you might have faced some challenges in your career.
Yes, it has now become fashionable to say that classical biology is not fashionable. And that I think is a wrong way to do. Because we discover a new technique, it doesn't mean that the old one is useless. Only when you add the power of the new technique to the existing old technique, then only it becomes very powerful. So we have to fight against this trend of saying that taxonomy is stamp collecting, organism biology is old fashioned, classical biology is dead. There are people who try to promote this, and I have spent a lot of time and effort fighting against this, both at the level of my students, level of my institution, at the national and also at the international level, promoting this idea how we can bring a synergy between these two. So I spent a lot of time trying to make classical biology fashionable or retain its fashion.
But this thing down the line, what I have realized over time, that students, they are attracted to these kind of techniques. And when they are attracted to these kind of techniques, the interpretation or deciphering a particular problem, that becomes difficult, because more emphasis is on the technique, but less emphasis is on logic or reasoning, that why it has happened, how it has happened.
So actually, there is a very simple solution to this problem, which we forget. If we get children interested in nature, when they are 5 years old, 6 years old, 10 years old, then that is the time they don't have any technique. That is the time they see, they are curious, they have questions, they are in love with nature. With that in mind, once they go to the university, even if they specialize in techniques, they will always realize that I can answer the question which I had when I was 10 years old, because now I have the technology. What we do is we make children study from books, don't watch nature, don't realize anything, and then suddenly we take them to university and teach them a technique. They have the technique, but they don't know what to do with the technique. And best way to solve this problem is, I keep saying, everybody is a born scientist. You don't have to have a degree to become a scientist, because science needs curiosity, logic, reasoning, which 1-year-old children show. So, we must make them scientists from the beginning, and by the time they are able to go to the university and learn some techniques, they already have lots of curiosity, lots of questions in their mind, then they will apply the techniques to them. That is what we need to do.
And also maybe in terms of development, when we are pumping lot of funds into these kind of say equipments and other things, and students, they look for fancy labs, that if that particular lab has that kind of equipment which is the recent one, and that somewhere also kills the cognitive abilities of the students, because they don't want to go to the basic stuff where they feel that they are a bit ashamed of that particular lab doesn't have that kind of facility. So, you have been propagating in a different way. So, tell me more about that.
Yes, this is a real problem, but there are two ways to solve this problem. First is, it is true that funds are distributed very unequally, very unfairly. There should be a lot more money for classical biology, organismal biology, evolution, taxonomy. So, one is to try and address this inequality and create little more equality. This I do in my capacity as a members of committee, as president of National Academy, as in all those capacities, I try very hard to make this. But that is not enough. What we need to do is, we need to realize that a lot of cutting edge research can be done with very little money. So, one of the major running themes in my career has been low cost research. Perform low cost research, make low cost research fashionable, interesting, give it social prestige. In fact, I tell my students, the same problem if two people solve, one with spending $1 million, another spending $100, who is the more brilliant person? The one who spent $100. Whereas now what we do, we automatically give respect to somebody who has $1 million. So, that has to go. So, I am trying to promote this low cost research in several ways. One is, I practice low cost research. Even if something can be done in a very expensive way, I would find an inexpensive way to do it. The other is, I promote this idea. In fact, I have written a whole book called How to Design Experiments in Animal Behavior, and the subtitle is Cutting Edge Research at Trifling Cost. So, I have described several experiments there, done by Nobel laureates, done by other people, done by us, which any student can do. No money is required, and lots of things can be discovered. So, I am trying to promote this idea and create respect for low cost research.
So, you have widely traveled internationally. So, where is the gap between Indian science and other developed nations?
Every scientist, and especially scientists in every country, see, what scientists fail to do is, they don't do what in other disciplines business people do this. They say, you have a new idea, you want to make a new product, they do a feasibility analysis. Is it feasible? Is it going to work? We don't do this. We don't do any feasibility analysis. So, we should find, for example, I say, why am I give a talk saying, why am I an organismal biologist? First is, I live in India. What are my problems? I don't have so much money. I don't have sophisticated laboratories. I don't have all the technology. What is my plus point? I have lots of students, lots of human beings, lots of biodiversity. So, I should choose a problem where I capitalize on my advantages and I minimize my disadvantages. So, organic biology becomes an automatic choice. So, in India, if scientists do not simply follow the fashion in the West and do what they are able to best, then we will only be second class citizens, we will only be competing with them, whereas we are not using what is good for us. Now, in America, if I am in America, I would say I have lots of money, lots of technology, no biodiversity, then I do a different kind of science. Now, sitting here, we are doing that kind of science, they want to come here and do this kind of science. So, if we understand and try to capitalize on our advantages, choose scientific problems where we are likely to be better than, be more competitive than people in developed countries, and there are many such areas, then this gap will be filled, and it is good for you, it is good for science, because the problems are being solved by the appropriate people.
And second is that specifically in India, what I have realized over time, that there is a gap between teaching and research. That one who is a good researcher sometimes is not a good teacher. And then there is a feeling that teaching is a different profession, research is a different profession.
Very strong feeling, and we have to break this. So I tell my students that I want to break many boundaries between research and teaching, between teaching and learning, and between student and teacher, between science and non-science, between biology and chemistry. All these boundaries are artificial, and we create them for some reason and then we reinforce them. We should break all these boundaries. In fact, you cannot be a good researcher if you are not a good teacher. You think you are. It depends what index you are using. You may say, I publish a paper. That doesn't make you a good researcher. So it is when I teach that I realize whether I have understood something or not. My best ideas for research come during teaching by questions that students ask. So you may be already a good researcher, but you will become a much better researcher if you also do teaching. And this we must understand and do that. Again, if we have too much money, then we go in one direction. I think it is nice that lots of scientists have to work on medium level budget or low budget or even no budget. Then you start innovating. See, when you have money, you have imported an instrument, you know what to do. Where is the innovation? If you don't have money, you say, I don't have this microscope. Is there some other way I can do this? So innovation comes. In fact, if you even look at the history of science, it will be surprising how people were so clever experiments were done when technology was not available. Once the technology becomes available, you forget all of that. So I read older classic books and I am surprised how they managed to do this without the technology. Today it's unthinkable because we are blinded by technology, and that has to change. In fact, in one of my recent articles, I wrote the following sentence. I said, I admire the engineers who make sophisticated instruments, because it is really something worth admiring. But my twin heroes are the engineers who make sophisticated instruments and the scientists who make do without them. Those are my heroes. Because making the instrument is a great thing. Using it is not so great. But managing without that, that's where innovation is required. So we need to learn how to. So it's good that, I would say it's good that everybody doesn't have lots and lots and lots of money. Then you will only do what can be done in expensive research. All the things that don't need much money will get neglected. And it's good to have. But we need to give social prestige to low cost research. Once we give that, then lot more problems can be solved.
And secondly, I have been discussing with you earlier even that the students, even the researchers or the professors, they go for the journals which have high impact factor. But at some stage we can't afford that. And they have a mindset that publishing in those journals will make them more reputed.
But it is not a mindset. Unfortunately, it's a reality. So where is the fault? The fault is with the committees. The fault is the people of the evaluators. If we change that, then people will not want to pay so much money and publish in journal. Why are they doing it? Because we are discounting Indian journals, for example, and favoring, or we are going by impact factor. And so at the level of evaluation, this has to change. Otherwise, I don't blame people. They will do what is adaptive for them. No? It is adaptive to publish in a high impact journal because you will get a job. So it has to change at that level. So that's why I say it is the senior most scientists, the scientists who sit in positions of power. It is their responsibility and only their ability to change the system. We can't ask young students and young researchers to sacrifice their career and publish in low impact journals. It is, we have to make publishing in low impact journal worthwhile. And for that, what should we do? We must read. People who evaluate have stopped reading. They go by these matrices. Read the paper. There was that has become old fashioned.
Yes.
So I tell my committee, read the papers. Say, how can I read all the papers? Distribute amongst all the committee members. I read 5 papers, you read 5 papers, somebody else reads 5 papers, and then we trust each other. We discuss. So again, make the decision process, making process also democratic. So one person wants to take all decisions, he has no time to read. Why should one person make all the decisions? Make the decision process democratic, make reading fashionable. And in fact, when people make a present in many academies, when we are electing new fellows, there is somebody in charge of making a presentation. So, this is the person we should elect. And they start telling me, he has published so many papers, he has got so many citations, he has got so much, this is impact. I said, I don't want to know that. What has he done? Tell me. Have you read his work? Explain his work to me. And that kind of thing I am trying to spread. So, when I was on these committees, I would actually give a mini seminar on each candidate, having read all of that. And then people will do based on. So, we have to break this chain somewhere, but the response, it has to start at the top, not at the bottom. We cannot penalize young people to publish in low impact journals and Indian journals and punish them when they look for it. It has to stop. This thing has to start at the top.
And the second problem basically in our country is that we have plenty of languages and dialects, and but most of the science which is being taught or read, that is in English. But somewhere it appears to me that there is a sort of lack of comprehension or understanding, because whenever we read something say in English, but if my native language is Punjabi, English, or say Hindi or Urdu, I try to contemplate in that particular language. So, wouldn't it be nice that it is somehow it is being translated or transmitted in form of vernacular languages?
It's absolutely necessary. What we are not realizing is that by using English exclusively, we are catering to an extremely small minority, and we have a large population which are being left out because of this, and they are no less bright, which means we are sacrificing a large fraction of our population in drawing our scientists. So, this is something very important, has to be done, but it should be done in a clever way. It should not be that I like this language, I don't like that language. In fact, for science, I feel that the language also has to evolve. Like today in my lecture, some people ask me questions in Punjabi. I understood a little bit of it. The last part, if I didn't understand, I asked somebody. So, I do not say, don't ask me in Punjabi, I don't know Punjabi. So, we can mix languages, we can mix words. When I talk to people, to the extent that I know, I use the word from that language. For example, I mix Kannada and English, Hindi and English, and try to see the purpose is to communicate, not to say my language is great. So, we must also become very tolerant of multilingual people. We must try to help each other, and we must also produce lots of resources in languages. People who can write in their languages must write. Now, fortunately, Wikipedia is available in all languages. We should use that. I once created a program where in the Center for Contemporary Studies, when people are doing this, I had a program where student assignment is the following. Write an article in your mother tongue, get it accepted by Wikipedia. You pass the exam. Now, they will do the evaluation. I don't do anything. You take any topic of your choice, write an article in your mother tongue, get it accepted, publish in Wikipedia. Then you pass the exam. So, even young people, lots of us can write for children. For example, there is a dearth of literature for children.
Yeah.
There are no people ask me, give me some book on insects which for a 10-year-old. Where are the books? We don't have. And all of us can do it. A PhD student can write a book for 10th standard student. We don't do it. So, we have to keep doing this in different languages, try to get a large fraction of our population interested, also become very flexible about this, mix languages. Don't worry about purity of language. It's not important that you speak pure Hindi. You mix Hindi, and many of our languages are related, you can understand. Take help. I ask one student to translate what another student is asking me. So, become tolerant of this, mix the languages, don't worry about purity of language, but also make efforts to translate into different languages. Often in translation, you discover new things.
Yeah.
Translation is not a mechanical process, it is a very creative process. Whether you are translating literature or poetry or science, it is a very creative process. And you have to really understand it if you are going to translate. So, I think a lot of us should do these translations.
So, you have been in a sort of premier institute or elite institute, and you have been visiting the state universities also like ours. So, how do you feel that this gap can be bridged? Because there is a huge gap in the mindset, maybe in the students also, in the teaching fraternity also, in the research also. And in order to evolve or grow as a nation, we need to bridge that gap. That is more important, what I feel personally.
Yes. No, the gap is real, but I think the gap is exaggerated. So, I spend a lot of time going to smaller colleges, smaller universities, schools all over the country, and I find the gap is in the following way. There is less money, more money. You get best students, maybe not students with higher marks, maybe not with lesser marks, but there is no gap in intelligence. There is no gap in curiosity, because if you take the trouble of speaking to the students in smaller universities, smaller colleges, use examples that they understand, take things that they are familiar with, speak as much as possible in their language. It is not that students in Indian science are more intelligent than students in small universities. It is not at all true. And that is why I feel so sad that they are being left out. Now, what is the solution? It's very nice to say I am going to make sure that all universities get same amount of money. I cannot do that. But again, that's where you must remove money as the important factor. People in a small college in a rural place, they have much more biodiversity than people have in the city. Use that, make that prestigious. If every school or college conducts surveys of their biodiversity in their premises, that itself they will learn, and so many of them will go on then to become specialists. I know many children who fall in love with something, butterfly or honeybee or something, and then actually take it on further. So, there is lots of scope of making better science, better education, better creativity. If we forget that first thing is to have everybody has the same amount of money, that is not going to happen. Money is not the most important thing. So, it is possible to bridge this gap at the intellectual level if we make the effort, definitely.
So, in the beginning you said that you are fond of Hindi literature also.
I used to be. Now, unfortunately, I don't get that much time. I also, I don't even get opportunity to speak very much, because I live in Bangalore, nobody speaks Hindi. But at one time I was very fond of Hindi. So, now what I do is I try to get Hindi audiobooks and listen to them. I try to do that, but it's not. I am also trying to do that with Kannada, because I have also been too much. I was born in Kanpur, and the first language I studied was Hindi. Then I spent first 8 years of my life I spent all over North India, mostly in the Punjab area, because my father was in the military, in the Indian Air Force. Then when I was 8 years, we moved to Chennai. Then I learned Tamil, and I never learned Kannada properly. Then we went to Bangalore, and there I studied English in school. So, I only studied Kannada properly after I got married and started speaking Kannada to my wife. So, I have less facility with Kannada, Hindi, even other languages than English. So, I am trying to correct for that by reading literature, by reading things, because that is something very enjoyable. I am trying to make amends now for this.
So, what message would you like to give to young students or young generation in terms of science or scientific aptitude?
So, I usually when I give talks, I have my first slide and last slide. First slide is, science is a playful, curiosity driven activity available for all, young and old, rich and poor, professional and amateur, teacher and student, doesn't matter. That is the first slide. My last slide I ask, so I say science should be democratic. In the last slide I ask, but why should it be democratic? For whose benefit? Not just for the benefit of the people, but for the benefit of science. Because science is one area in which your authority has no meaning. The humblest young student can challenge a Nobel laureate and say, maybe this is wrong. This cannot happen in other fields. Science is one field. Therefore, we need lots of young, humble people having the opportunity to challenge authority. Science grows, science becomes robust by challenging authority. Anybody can call into question a well established fact, provided you use the reasoning. And so, for the sake of science itself, you need this democracy, not just for people. So, I begin by saying it is meant for everybody, and then I say it is necessary for everybody.
So, thank you, Professor Gadagar. It was a pleasure talking to you, and I hope the viewers will enjoy the talk. And if you need to interact with him, he writes in the wire also. That,
Yes.
yes, more fun than fun.
Yes.
So those articles are very interesting and they are quite understandable, easily understandable to non-scientific persons also. So thank you very much.
Thank you. I enjoyed this conversation.